Okay, on this example, we're given a demand function, a supply function, and we're looking to answer some questions. First, the equilibrium point, then we're going to compute the consumer surplus, and finally the producer surplus. So let's get started with finding the equilibrium point. So this is going to be an ordered pair. Our input value is going to be a Q value, and our output value is going to be a P value, a price. So to do so, let's go ahead and set these equal to one another. So negative 0.8 Q plus 150 has to equal our supply 5.2 multiplied by Q. Now this is a linear equation, so it shouldn't be too bad to solve down. I'm going to go ahead and add 0.8 Q to both sides. That'll get all of our variables on one side, leaving us with 150 equals 6Q. To isolate the Q further, we'll go ahead and divide both sides by 6, and I got Q to be 25. So that answers the input value is going to be 25. We still need an output value to go with this. So what we can do is we can take that value for Q and we can replace it in, evaluate either one of these functions that was given to us at 25. Now I'm going to go ahead and plug it into the supply function. So evaluate the supply function at 25, 5.2 multiplied by 25. I got this to work out to be 130. We would get the same result if we plugged into the demand function as well. All right, on the next part, on part B, let's go ahead and find the consumer surplus. So to get this, what we want to do is integrate from 0 to our value for Q, 25. And this one's going to require us to integrate the demand function. So negative 0.8 Q plus 150 dq at the end, and then we subtract off our equilibrium point multiplied together, the Q value multiplied by the P value, quantity multiplied by price gets subtracted away. All right, from here, let's go ahead and integrate. So we're going to use the power rule a couple times. We go Q is now raised to the second power. We're going to divide by that new exponent of 2 plus 150. We'll go ahead and put a Q with that. This will be evaluated between 0 and 25 minus 25 times 130. I got to work out to be 3250. All right, from here, let's go ahead and fill in with our upper bound and subtract away when we fill in with our lower bound. So negative 0.4 times 25 squared plus 150 times 25. That was our upper bound. Now we subtract away as we fill in our lower bound. 0.4 times 0 squared plus 150 times 0. Still minus that 3250. And I got this to work out to be, the second part, all of this is going to be 0. So this works out to be, as I put it in my calculator, 250. So a consumer surplus of $250. All right, on part C, we want to do the producer surplus. So this is a little bit backwards. What we want to do is first multiply together our equilibrium point values. So 25 times 130. And then we subtract off the integral from 0 to the Q value for the equilibrium point, the 25. But this time we're going to use our supply function. So 5.2Q goes in here with a dq at the end. Now this still works out to be 3250 as 25 times 130. Now minus 5.2 Q to the second power, and then we divide by our new exponent, evaluated between 0 and 25. So 3250 minus 2.6, 5.2 divided by 2, and then we'll evaluate at our upper bound, subtract away that 2.6 evaluated at our lower bound as we fill that 0 in as well. Now again, when we multiply by 0, this part goes away. That makes a 0, so subtracting 0 or adding 0 is not going to make a difference. So really it's 3250 minus 2.6 times 25 to the second power, which I got to work out to be $1,625. So I hope this helps out as you're trying to set up, find the equilibrium point. find consumer surplus, and find producer surplus. Good luck.